Hi everyone, welcome to this YouTube channel, Best Science Brain YouTube channel. Today we are still continuing on WAEC 2024 qualitative analysis on specimen C. We have done the first model or the first video on practical specimen C 2024 WAEC. So if you have not seen the video, search our videos on this channel, Best Science Brain. You're going to see qualitative analysis on specimen C, WAEC, May, June 2024. Watch that video before you come to this particular video, please. So today, we're going to analyze the result we obtained from that reverse experiment on specimen C. That's the video we have already done. We're going to discuss the results, why the answers or the results we got is like that. Then after the analysis of this result, we are now going to also perform a new experiment on the same specimen C. You know that WAEC has ways of asking questions in different perspectives. So we're going to do another analysis or qualitative analysis on specimen C, but with different questions. So we're going to have two different experiments on specimen C. The one we want to discuss now, which we have done already in the video, and then we're going to do also now after the discussion of the one we are already done. We're going to do a new experiment. So stay connected to the channel, and then we say thumbs up to our subscribers, those who have been subscribed to the channel. We appreciate you all. And then our subscribers in all of our African countries, and then those from Asia, Europe, and America that also are subscribers on this channel. We appreciate you guys as you stay connected to watch us teach students and prepare them for May, June 2024 WAEC examination. We appreciate you guys. Then those of you that are new viewers, or those of you that are random YouTube searchers, you come across this channel for the very first time. This is the best channel you can ever have in terms of online education. So all you have to do is you go to as the video is playing, you look down under the video, you're going to see the channel's name, Best Science Brain. Then under the channel's name, you're going to see a pear-shaped bell, a tiny bell, written subscription on it. Tap on that pear-shaped bell, tap on the subscription bell only once, and get subscribed to the channel. So you'll be seeing our videos. We're going to run out. We're going to do so much practicals, not only chemistry, and we're going to see work on physics. So in this WAEC 2024 May June examination. So stay connected as we start the discussion of the analysis before the experiment. So this is the previous question that we have done, the experiment on this channel. We're trying to now discuss the result. WAEC 2024 qualitative analysis model 1. Question says, C is a mixture of two simple inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gases involved, gas or gases involved. I repeat myself. C is a mixture of two simple inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gas or gases involved. 2AI says, add 10 cm cube of distilled water to C, stir thoroughly, and then filter. Keep both residue and filtrate. Add 10 cm cube of distilled water to C, stir thoroughly, and then filter. Keep both residue and filtrate. So we're going to go over to the whiteboard, analyze the results, see observation and inference, and then analyze what we got from the experiment. So we have our report: C plus 10 cm cube of distilled water, stirred and filtered. That's the experiment. Observation we got was the two salts reacted in the presence of water to produce a white precipitate. Filtrate is colorless and residue is white. Go to the inference. Inference says C is a mixture of two soluble salts. reaction is double decomposition, in bracket, precipitation reaction. So we're going to now analyze this result and see what we can make out of it. We'll go to the analysis. C contains lead nitrate or lead 2 trionytrate 5 and sodium triazocarbonate 4. These two salts are soluble salts. All triazonitrate 5 salts are soluble in water. All common salts of sodium are also soluble in water. So you don't expect them, having it been that we'll have them in two different test tubes and we'll add water into them, they will all dissolve. But since they are mixed together, they're going to be a reaction. So let's look at what's going to happen. We have lead nitrate, PbNO3, aqueous means in place of water, plus sodium carbonate, aqueous in the place of water, giving us lead. Please ionize this into lead ion and NO3 ion. This breaks into sodium ion and the carbonate ion. Move on light charges together. Equal valencies cancel out. When I have PbCO3, the product lead carbonate, then join these together. Now sodium nitrate produced. Sodium salts are soluble or all nitrate are soluble. This is aqueous. This is the colorless filtrate obtained after filtration. While carbonates are soluble, are insoluble except those of sodium, those of group 1 and that of ammonium. Group 1 elements like sodium, potassium, lithium, their carbonates are soluble, while other carbonates are insoluble. Ammonium carbonate is also soluble. So this is solid or insoluble. This is the white Precipitate form when these two salts reacted. So, and this becomes our white residue. So that confirms that the answer is correct. And reaction that involve two soluble compounds. This is soluble. Alcohol means to produce one soluble and one insoluble is called double decomposition reaction or precipitation reaction. So we'll go over to 2A II that says test the filtrate with litmus paper. Test the filtrate with litmus paper. To go over to the board and then discuss our result as we obtained in the previous experiment. So we have a report 2A II filtrate plus litmus paper. And we have done this experiment. You go to the previous video in the channel and watch it. So our observation was filtrate had no effect on blue litmus paper, but change red litmus paper to blue. And that means that filtrate is what? Alkaline or basic. You don't say that filtrate is base or is a base or alkali. No. It can possess a basic property or alkaline property. That doesn't mean that it's a base. So filtrate is alkaline or filtrate is basic. So that explains question number 2A II. So go over to question 2B that says to 2 cn cube of the filtrate, add 2 cn cube of iron 2 sulfate aqueous followed by slow addition of 1 cn cube of moderately concentrated H2SO4. I'll come again. To 2 cn cube of the filtrate, add 2 cn cube of ions 2 sulfate aqueous followed by slow addition of 1 cn cube of moderately concentrated H2SO4. So the B part says, we divided the B part into two. The first part is addition of iron 2 sulfate. Second part is addition of conc H2SO4. Because we got different observations when we did it. So filtrate plus 2 cn cube of iron 2 sulfate aqueous, you obtained filtrate turned green. The filtrate turned to a green solution. That was observation. Then plus, when I said 1 cn cube of concentrated H2SO4, we have a brown ring formed between the layers of the two liquids. I will now have NO3 confirmed. NO3 confirmed. So let's analyze this result. The filtrate is, as it's discovered, is sodium triosonitrate 5 aqueous. And the first test was to add, the first reagent added to is iron 2 sulfate. So we have sodium ion split from NO3, iron 2 split from SO4. Move all items together and get the product. Iron 2 combined with nitrate giving you FeNO3 bracket 2 aqueous. Why this combines with that giving us sodium sulfate aqueous. So we say that the filtrate turned green. The filtrate turned green. So that means the green solution we see when we added the iron sulfate is due to the presence of iron 2 triosonitrate 5. Since you know that iron 2 salts are green in solution. So that was the filtrate turned green. And under the inference, we didn't write anything. Why didn't we write anything? Because we already know that the reagent we added is what? Iron 2 sulfate. So since we know that the reagent added is iron 2 sulfate, no need to say iron 2 present because that green color indicates the iron 2 salt you added, since iron 2 salts are green in color. Then the next one, we added 1 CnQ of H2SO4. You observe a brown ring. So that brown ring comes due to the reaction between FeSO4. What is FeSO4 you're using? Or, okay, reaction between FeNO3, the nitrate salt formed, and H2SO4. And what again? What else is added? We added nitrate and then iron what? Sulfate added. That is the two reagents here. I'm going to the complex of this nature. We're going to have a complex of this nature. Fe of this nature, FeSO4.NO. So this complex is what gave us the brown ring. The brown ring form. So with what experiment, you're going to see the brown substance hanging in the test tube. The lower region or the bottom of the test tube is our conc H2SO4. So that is the brown ring test. 2CI says transfer the residue into a boiling tube and add 5 cl of dilute HCl aqueous. Transfer the residue into a boiling tube and add 5 cl of dilute HCl aqueous. So we'll go to the report on the whiteboard and then discuss this result. So we have residue plus dilute HCl aqueous plus heat. That's the report. So the heat may come there or not. But the residue, remember the residue is lead carbonate plus dilute HCl. What we observed was we had a brisk effervescence. Effervescence means gas liberation occurred, liberating a colorless, odorless gas, which turned moist blue what? Lace paper red and lime water milky. And the gas that has this characteristic is carbon 4 oxide. Inference, gas is CO2. The anion that gives carbon 4, that is carbonate ion, CO3 2 minus, confirmed. So in analysis, residue is lead carbonate. These are residue from the filtration process. We're adding HCl to it. Add HCl to it, what happens? This plays into this is an insoluble salt, but the acid will dissolve it, giving us lead 2 ion and then carbonate ion. The acid break into hydrogen ion and chloride ion. Moving all items together, we're going to have lead 2 chloride, which is solid, and then these together giving us H2CO3 acid. When you combine these two, this acid is unstable. Being unstable is placed into water and CO2. So the products now become water and CO2. So the CO2 came out as a gas. that will have the effervescence taking place, gas vibration, as you observe in the experiment. Then we say that the CO2 turned lime water milky. When this gas was passed through lime water is basically calcium hydroxide, the lime water. So when we pass CO2 through lime water, there's a reaction that occurred when we did the experiment. And the reaction is what we're writing down here. We have calcium carbonate and water produced. The calcium carbonate produced is white in color or milky in color. So that was why we say it turned lime water milky. So that's the chemical process that took place. So you need the balance equation for this one. There is two. You can put two here to balance this equation. And so although this is just analysis, it's not part of the experiment. It's for you to understand what happened during the process. Go over to question 2CII that says boil the mixture from 2CI and allow to cool. Boil the mixture from 2CI and allow to cool. To go over to whiteboard for our observation and inference and discussion. So go over to our report 2CII. Say mixture from 2CI. The mixture from 2CI is the mixture that contains the residue and HCl, liberated carbon dioxide, plus heat and allowed to cool. Observation will have white precipitate dissolve on boiling and reappeared on cooling. Inference is lead-2 ion from lead-2 chloride. Lead-2 ion from lead-2 chloride. We go to analysis. How the reaction, which already written before, between the residue lead carbonate and HCl, that liberated carbon dioxide. Remember, a salt was formed. What is salt formed? Lead-2 chloride, which is an insoluble salt. And how this salt behaves when it's heated on boiling, it do what? It will dissolve on boiling and does what? Reappears on cooling. So this is the white PPT formed when the lead carbonate residue reacted with HCl. It formed this, even though a gas came out. So the white PPT, when it was heated, dissolved on boiling and reappeared on cooling. That's why we have the inference lead-2 ion from lead-2 chloride confirmed. We'll now have question 2D, which is said can serve as alternative for question 2C. The 2D says transfer the residue into a boiling tube and heat strongly. Transfer the residue into a boiling tube and heat strongly. Transfer the residue into a boiling tube and heat strongly. So go back to the whiteboard and discuss our observation and inference. So go to our test, residue plus heat. Residue plus heat. So you have to heat the residue without adding any reagent into it. And observe what will happen. The observation is residue decomposes, liberating a colorless, odorless gas, which turned moist blue, little faint red, and lime water milky. And you know the gas should be CO2. Then at the end of heating, we obtain a deposit. We say reddish brown deposit was obtained after heating. Then the inference, gas is CO2 from triazo carbonate 4 ion confirmed. Reddish brown deposit is lead-2 oxide. So let's explain why it's like this. We'll go to analysis. The residue is lead carbonate. That's the residue. When heated, we decompose into lead oxide, liberating carbon dioxide. That's the gas that turns lime water milky. While lead oxide is reddish brown deposit. So that is it. Okay, we are done with the analysis of the experiment we did. If you are just joining us for the very first time on this YouTube, as I said before I did the experiment, please search our channel, Best Science Brain, search it, look for WAEC May June 2024, qualitative analysis of specimen C. go through the experiment first, then you understand the discussion of the experiment. So what we will discuss for the result we obtain for that experiment. I will call that experiment model 1. Model 1. So now we're going to continue again. We're going to run another experiment on the same specimen C. But this time around the equation is twisted in a different way, which we call model 2. So if you're writing SSCE exam this year, you must completely watch model 1 and model 2, copy out the equations, copy out the solutions, and take your time to study it. The question can come out as model 1 or can come out as also model 2. So WAEC has a way of asking questions, and they are very, 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 very what? Very, very smart in asking questions. So you have to be prepared very well. So, and this qualitative analysis has no endpoint. It's not iteration. So this the solution to this number 2 is the same in all schools in West Africa. And then the countries that are WAEC in West Africa, you should know them. Nigeria, one of them. Ghana, Gambia, Sierra Leone, and Liberia. 5 countries involved in this examination. So that number two question, which we are treating now, is the same thing. The specimen C, which is lead, nitrate, and sodium carbonate. The question can come out in form of this one we have treated, we have done the experiment, and the one we're about to do the experiment just in a few minutes from now. So stay connected as we continue. So we have WAEC May, June 2024, qualitative analysis, model 2. Says, sees the mixture of 2 inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gas or gases involved. Sees the mixture of 2 inorganic salts. Carry out the following exercises on C. Record your observations and corresponding inferences. Identify any gas or gases involved. That is 2A. That should be number 2A, not 1A. 2A. Add 10 cn cube of distilled water to C. Stir thoroughly and filter. Keep both residue and filtrate. Add 10 cn cube of distilled water to C. Stir thoroughly and filter. Keep both residue and filtrate. That is number 2A. So let's go to the whiteboard. 2A, report our experiment. C plus 10 cn cube of distilled water stirred and filtered. So you see that this experiment is the same thing as the one we did before in model 1, the same experiment. I'm going to supposed to have the same kind of observation and inference. But as we go on, we're going to see where the questions differ. Okay? So we'll go over to the experiment. So this is specimen C. That's our C. We're adding water to it. They say 10 cn cube, so add enough quantity. That will be more than 3/4 of the test tube. You can stir it, or you can shake it vigorously. Okay? So I can make the rate of reaction vigorous by shaking. So you have that, the kind of white suspension formed. Okay, we're going to filter this. Before we filter this, we're going to first of all write our observation. Or first of all, let's filter before we write our observation, please. So this is our filter paper. We fold it, the way we normally fold it, into a semicircle first, 2 equal halves. Then fold again into a cone. That is it. When you have done that, you have 2 openings, either this or that. You close one of them and open one. Form a cone, a funnel shaped cone. Then take your funnel. You can sprinkle some water on the walls of the funnel to act as a kind of adhesive. Then put the pepper into the funnel to make it lap. The water will make it lap in the funnel. Then get a clean test tube and then shake your. You can see the mixture. You can see the white sediment under, and the top layer is somehow getting clearer. So before you filter, you have to shake the mixture once again to obtain a kind of homogeneous mixture, and then pour it into the filter paper. Allow it to start draining so you can get your filtrate. So you see that. So I can keep this mixture inside the test tube rack to stand on its own. Add more water to this. Still have some solids remaining inside. Shake again. Shake very well. And then let me add more because there are some grains remaining here. So why it will dissolve. So shake very well. Let me add more water. Okay. And then add more. You see the filtration is still in progress. While having a clear filtrate. It's not like there's contamination there. Am I right? There are some white substances appearing. So that means because of this contamination, I will refilter. I'm going to refilter the filtrate. But the filtrate should be a colorless what? Solution. So I'm going to refilter it because it's more like the filter part is not good. It has white pores. So I'm going to when you have a perfect filter paper, you have a good filter part, you don't have this problem. So since we have this suspension of white substance inside the filtrate, I'm going to refilter the filtrate. So what would I do? Instead of wasting time, I'm going to transfer the mixture into another test tube and then refilter the filtrate. Okay? Alright. So we want to refilter the filtrate, get another clean filter paper, fold it again into two equal halves and fold again to get the shape of a cone or a funnel shape. Then open one of the partitions while you close one. Then get a clean filter funnel. Sprinkle some water in onto the walls of the funnel. When you have done that, then insert this. Let it lap on the funnel, and then put it inside. When you have done that, so this is the suspension, the filtrate that is impure. Want to refilter it again because you're seeing some substances hanging inside it, the white substances. So you refilter it so that you get a clearer filtrate or you get a better separation. So let's see what will happen. So we now have the filtrate, colorless filtrate obtained after the second filtration. We have it. Then we have a white residue. A white residue. So we open the residue on the table. Keep the filtrate here. Put the residue. The filter on the table, please. And allow it to dry. Allow it to dry. You can see that. So let's go to the whiteboard and report our work. So our observation is the two salts reacted to produce a white precipitate. Residue is white and filtrate is colorless. So that confirms the same experiment we did before. The first model that we did, the same observation. As inference, we say that C is a mixture of two soluble salts. Reaction is double decomposition, otherwise known as precipitation reaction. We have analyzed this already. We explained the analysis. We discussed the result before. So it's the same thing. So go to the second question. So 2B says, test the filtrate with litmus paper. Test the filtrate with litmus papers. Test the filtrate with litmus papers. Go to the board and report our work first. So our experiment says filtrate plus litmus papers. Filtrate plus what? Litmus papers. So go and do the experiment and then come back and write observation and the inference. So that's the filtrate, that's the blue litmus paper. So we'll have to dip it inside for a few seconds to touch the filtrate. There is no effect on the blue litmus paper. That means filtrate is not acidic. We'll now take the red paper, take just one strip of it, and then dip it inside to touch the filtrate. Any change? Yeah. Yes, it's a change toward blue. The same effect, the same thing we experienced in the first experiment, confirming that we are right. Okay? Our observation, filtrate had no effect on blue litmus paper, but change red litmus paper to blue. You underline the colors. It is wrong to say that it changed litmus paper to blue. You must mention the first color, red, before the second color, blue. So the inference, we say filtrate is alkaline or basic. So go to 2BII that says to 2 Cn cube of the filtrate, add 2 Cn cube of iron sulfate aqueous, followed by 1 Cn cube of moderately concentrated H2SO4 aqueous. I come again to 2 Cn cube of the filtrate, add 2 Cn cube of iron sulfate aqueous, followed by 1 Cn cube of moderately concentrated H2SO4. So we're going to report this test. We're going to report this and split the addition reagent into two. First of all, we're going to write filtrate plus 2 Cn cube of aqueous iron sulfate, and then we'll now write plus concentrated H2SO4. Since we're adding two reagents, so we're going to report the observation we get when we add each reagent differently from the other. So this is the filtrate. We'll collect 2 Cn cube of the filtrate. We need 2 amounts. We're going to add our iron 2 sulfate into it. See, it turns green. Then we'll now add concentrated H2SO4. You slant it. Slant it to avoid accident. And then keep it away from your neighbor's face. And be careful with acid. So moderately concentrated. And most of the time, your teacher should help you do it. and then you gotta report your work. So it's boiling. So have a kind of brown ring being formed in the mixture. Have at the surface a ring being formed. So this is the brown ring test for NO3 ion. Have a meniscus give a kind of brown ring. So having done that, report our work. So report our observation. Who added iron sulfate, iron 2 sulfate, we say filtrate turned green. We'll report no inference here. No need to say iron 2 present because it's iron 2 reagent that you added. Iron 2 reagent is what gave you the green coloration. Then we now say plus 1 Cn cube of concentrated H2SO for aqueous. This place you write a brown ring formed between the layers of the two liquids. Then under your inference, you write NO3, triiodide ion, confirmed. So remember that the filtrate is sodium nitrate. So in the filtrate, we confirm the anion by the brown ring test. We already explained this test in the previous experiment. And you look at question 2A to 2B, the same question that we used in the previous experiment. When I'm going to 2C, the 2C will differ from the one we have in the previous experiment. 2CI says transfer the residue to a boiling tube. Add 5 Cn of dilute triiodide acid and boil the mixture. So this 2CI is different from the first experiment that we did. In that one, we are asked to add HCl. But in this one, we're adding dilute HNO3. So we change the acid this time around to the residue. Transfer the residue to a boiling tube. Add 5 Cn of dilute HNO3, aqueous, and boil the mixture. So report our work. So go to 2CI. Now it's a residue plus dilute HNO3 aqueous plus heat. The heat may not be mandatory. Remember the residue is lead carbonate. And when I add an acid to carbonate, expect CO2 to come out. So this is the residue. We use a small spoon or spatula to scoop the residue into a neat boiling tube. When you want to boil, you don't boil with a test tube. You boil with a boiling tube. Are you following? It's thicker and wider. If you boil with a test tube, it will crack. And then the content will extinguish the Bunsen burner. So you don't boil with a test tube. Any experiment that involves heating, please, you transfer the content into a thicker glass called boiling tube made of pyrex. So we can collect more residue. And then we can now add our acid, HNO3. The other experiment we did, we used HCl. This time around, we're going to use HNO3. When we use HCl, we observe that at the end of boiling, we got a white residue of lead chloride. But let's use HNO3 and see what would happen. So this is the residue. This is the acid, HNO3 acid. So I will keep the residue in the test in a slanting position and be careful of your clothes, and carefully run the acid into it. Are you observing anything happening? Now bubbles. That is gas what? Liberation. It's a tiny, tiny bubbles. So that's what called effervescence. So I'm going to close the tube fast. So that I don't what? Where the whole what? Gas. Are you following? So we are heating the mixture of residue and HNO3. And then we connected the boiling tube to a round bottom flask containing lime water. So we have to heat, as you see some bubbles rising from the mixture, from the hard glass tube, that mixture of C and HNO3, showing that a gas is coming out. So, and we expect that the gas should be carbon 4 oxide. So we shall allow this to boil and boil further. As you boil, as a precaution, as you boil, you try to rotate the hard glass tube over the fire. Because if you don't do that, you boil over one particular part, it may burst. You see, so much gas is coming out. So gas is coming in large amount. So the heating continues. So as you observe, the lime water has turned milky in the bottom glass. That means we'll have a large amount of CO2 liberated. So we'll continue the mixture to make sure that residue dissolves very well. See that the gas is still coming out in large amounts. The next thing I will do is to test the gas with litmus pepper. So the next I will do is to test the gas with moist litmus pepper. So I continue heating and make sure that a large amount of the gas comes out. See that it's more like the residue has completely dissolved. So depending on the quantity of residue you have little quantity, it will dissolve on time. If you have large amount, it will take some time to dissolve. So as I said, when you heat, try to move the hard glass tube round over the fire. Don't keep it at one point so that it will not burst. Okay? And don't slam the tube on somebody's face. So you have to be very careful. So you don't pour hot water on yourself or hot solution on yourself. So go back to the heating process. Listen around. You want to test the gas with litmus pepper. The gas is coming out. Put it back close to the top of the tube and see whether there's going to be any effect. So, can you test? So the paper has turned, look at the tip side, the top side, has turned what? Red. Red, yeah. So that CO2 is slightly as big gas. So it's okay. Should be brisk effervescence, liberating a colorless, odorless gas, which turned lime water milky, residue dissolved to give a colorless solution. So under your inference, you write gas is CO2, CO32 minus present or confirmed. Then, of course, you can still put gas turn what? Blue what? This part what? To faint red. Before you say turn lime water milky. Okay? Analysis, they analyze what happened here. Residue is lead carbonate. And we added which acid this time around? HNO3, not HCl, as in the former experiment. So with HNO3, we have this lead ion, carbonate ion, hydrogen splits from NO3 ion. Marrying unlike terms together, we now have H2, we have lead nitrate, that is it, aqueous. Then this will give you H2CO3, which splits into water and what? CO2. We now have water and CO2 liberated. That carbon 4 that is liberated. Then why did the residue dissolve? Because lead nitrate is a soluble salt. All nitrate is soluble. Had it been that we use lead, we use HC as the previous experiment, we have lead chloride, water, and CO2. Lead chloride is insoluble. That's why we have a white precipitate letter on the first experiment we did, or we explained. So, but we're using HNO3, we have a soluble salt. That what we have here, we say residue dissolve to give a colorless solution, because residue, the solution, the salt form is a soluble salt, since you know that all nitrate salts are soluble. Okay? You see, the difference between the two experiments lies start from question number either 2C or 2B. You compare it and see they are not exactly the same. 2A and B are the same, but the compound half of it, or the third half of it is different. In the third half, we added HCl, but here we're adding HNO3. Question CII says, to 2 Cn cube of resulting solution from 2Ci above. To 2 Cn cube of resulting solution from 2Ci above. Add sodium hydroxide in drops and then in excess. The solution, what solution I'm talking about? The solution we obtain after reacting the residue with HNO3, that is from 2Ci. So we add to 2 Cn cube of this solution from 2Ci above, add NaOH in drops and then in excess. So we'll go to report our work. 2 Cn cube of solution from 2Ci plus sodium hydroxide aqueous in drops. They leave a line under it now say plus sodium hydroxide aqueous in excess. We're going to do this experiment and report our observation and then corresponding inference. Obtain after heating the residue with HNO3, that's the 2Ci. We'll collect a little amount to present our 2 Cn cube in a clean test tube. See, we have that obtained. Then we're adding NaOH, sodium hydroxide in drops. So this is the continuous sodium hydroxide. And then in essence, we add in drops first, little amount. We have a dropping pipette, use the dropping pipette to collect a little dropping pipette. That has rubber tube at the end. If you don't have it, you can just add. Be very careful, add little amount, just a drop. Are you seeing it? What do you observe? A white what? Precipitate. You can see it very well. The substance is not soluble, it's hanging. Are you following? So that is in drops or add excess. Now excess means I'm going to add more of this sodium hydroxide. You can see some solids inside, like chalky in appearance. So I add more. This is not white gelatinous, please. So this is white, or you can say chalky white. White gelatinous is different. Gelatinous white looks like the gel, gelic in nature. So we're going to add more of this. Excess means add all to half of the test tube. So, are you seeing it? What happened to it is what? They are dissolved now because it's clearer now. Everything is what? Off, clear, transparent. So the white PPD what? Dissolved. In excess was sodium hydroxide. Which cation do you think is present here? What for cation? Zinc. Which other one can be present? Lead. Which other one can be present? Cash. Which other one can be present? Aluminium. Calcium is not there because calcium forms a Y PPT in drops. But in excess, it will not, it remain insoluble in sodium hydroxide. Okay? So the cations you suspect should be lead, aluminum, and what? Zinc. But I will not write aluminum and zinc. You can tell us why. I will not put aluminum and zinc because it's not what? Gelatinous. Are you following it now? If it's white gelatinous, I can include what? Aluminum and what? And zinc. So let's report our work. So the test, 2 single solution from 2Ci plus NaOH aqueous in drops. In drops, we have white, in bracket you write chalky, close bracket, precipitate, formed. White chalky PPT formed. Under inference, you have to be logical. You now write lead 2 ion, comma, calcium 2 ion present. These are the cation that give us white PPT with sodium hydroxide. Since we will not put the word gelatinous, the gelatinous is not there, so you don't have to put aluminum and zinc. Okay? In excess, what happens to it? It dissolves. You now say white, in bracket, chalky, precipitate, dissolve to give, don't say soluble, the word is dissolve, to give a colorless solution. Then under inference, you write lead 2 ion confirmed. Please, when you have 2 cations, like in this case, lead and calcium, don't put and, please. Put what? Comma. That comma means what? Or, lead 2 or calcium. When you put and, you are wrong because the salt is only one salt. So it cannot contain 2 cations. It's a simple salt, not a double salt. Lead 2, comma, calcium. Or if you want to use the word between, you can say or. Don't say and. That is wrong. Okay? So that is our result for this. So let's go to the analysis of this work we did now. Remember that the solution is lead nitrate. And we added sodium hydroxide in drops to it. When we add this, we're going to have lead 2 hydroxide and sodium nitrate. Lead 2 nitrate is soluble. The lead 2 hydroxide form is the white or chalky white PPT form when we added this chemical in drops of it. So the white PPT is the lead 2 hydroxide. Then we proceeded to add the sodium hydroxide in excess. That is more of the chemical in excess. In excess of this, lead will now form a complex salt with what? Sodium hydroxide. So while lead 2 hydroxide was able to dissolve in excess because it complexes with sodium hydroxide, giving you this salt Na2PbOH4. So this salt is called sodium tetrahydrosoplumbate 2. Sodium tetrahydrosoplumbate 2. So that is salt form when we added this chemical in excess. And complex salts are soluble. So that way in essence, what happened to it? It dissolved. Give you the solution form is this sodium tetrahydrosoplumbate 2. So go to the next question. So question 2C says to 2Cn cube of resulting solution from 2Ci above, add NH3, that's aqueous ammonia, in drops and then in excess to 2Cn cube of the resulting solution from 2Ci above, add NH3, ammonia in drops and then in excess. Go to the board and report our work first. So now 2Cii, 2Cn cube of solution from 2CI, the one we added, the one that has this residue and HNO3, that is 2CI, plus aqueous ammonia in drops. We'll now go to the next line and write plus aqueous ammonia in excess. You see that? Okay, we'll now have collect 2C and again of the solution. We got 10 from heating. Your little amount will be okay for the test. When I add in aqueous ammonia, this is ammonia. We add just little drop and then in excess. We add the ammonia in drop. You know the same thing we got before? Yes. The same white, you more chalk itself. White chalky precipitate form in drop. Then we add in excess. Did it dissolve? No. But if it dissolve, it would have been what? Colorless. I follow you. So with the same lead is present. Because the lead behaves in both what? Ammonia and sodium hydroxide. In sodium hydroxide, in both ammonia and sodium hydroxide, in drops, it gives you a white or chalky precipitate. When in excess, it will going to dissolve in sodium hydroxide because it compresses sodium hydroxide in excess. But in ammonia, it will not dissolve. Okay? Report our work now. Observation in drops, we have the same thing we have here. White, chalky, precipitate formed, and that we still write only lead. I'm going to write calcium. We'll not write calcium because calcium doesn't give any chemical reaction with ammonia. I will not write aluminium or zinc because we do not put the word gelatinous. You report what you see. Then, in excess, we'll now say white, chalky in bracket, PPT or precipitate remained insoluble. So, I write lead 2 ion confirmed. I would have said aluminium. Remember that aluminium does not dissolve in excess sodium hydroxide. Ammonia. But why didn't I put aluminium? Who can tell us? Because the word gelatinous is not there. Okay? So we're going to go and analyze this work and see why it is so. The mixture contains lead nitrate. And we're adding ammonia to it. Ammonia solution is nothing but ammonium hydroxide. That is aqueous ammonia. So this splits into lead 2 and NO3, ammonium ion, and hydroxide. You produce lead 2 hydroxide and a changing of items and then a changing valency and ammonium nitrate, which is aqueous. So the white or chalky PPT is lead hydroxide. So when you add aqueous ammonia both in drops or in excess, you produce this chemical or this substance. In excess, you see how the same substance because lead hydroxide does not complex with ammonia. So it remains lead hydroxide both in drops and in excess. Go to the next question. So the 2CIB says, to 2 cn cube of resulting solution from 2CI above, add 2 cn cube of potassium iodide aqueous, or in bracket, be given potassium tetrahydrochromate 6. Potassium tetrahydrochromate 6. So any of these reagents will give you the same result. Either you are adding potassium what? Iodide, Ki, or potassium what? Tetrahydrochromate 6. They will give you the same result. So one of them will be brought out. They can't bring the two of them out. Okay, we'll go to our report. So 2BIV, say 2CNQ of solution from 2C. I remember the solution from 2CI, the one we heated, the one that contained residue and HNO3, plus, let me say, 2CNQ of potassium tetraoxochromate 6 or iodide. Any reagent that is valuable give the same result. So let's go to our report. So correct the error. The question is 2CIV, not 2BIV. 2CIV, please. So this is the solution we heated. I'll collect under 2CNQ of it. And then I'm going to add the chemical potassium iodide or potassium tetraoxochromate to the resulting mixture that it was heated. Solution that was heated. Are you seeing it? So what do you observe, please? Yellow what? Yellow what? Yellow precipitate because it's solid now. And that tiny solid inside it. And that detects solid 2 ion. Whether you use potassium tetraoxochromate 6 or use potassium iodide, you get the same result. Okay? So let's report our work. Yellow precipitate. Formed. Lead 2 ion. Confirmed. We'll now go to 2CV that says to 2CN cube of the resin solution from 2CI above. Add 5CN cube of dilute HCl. Boil the resulting mixture and allow to cool. Come again. To 2CN cube of the resulting solution from 2CI above. Add 5CN cube of dilute HCl aqueous. Boil the mixture, resulting mixture, and allow to cool. 2CV says 2CN cube of solution from the same 2CI that was heated, that the lead nitrate, plus 2CN cube, 5CN cube of dilute HCl aqueous, then plus heat and allowed to cool. Before we carry out this experiment, we're going to analyze this order, the 2CIV, that of a solution from 2CI plus potassium tetraoxochromate, tetraoxochromate 6, or plus potassium iodide. So let's see what will happen here. So we'll analyze this result before go back to the experiment. So let's go to analysis. So the mixture from 2C that was heated contains lead nitrate. And we are adding potassium tetraoxochromate 6 solution to it. We're going to form lead tetraoxochromate 6, and is a solid. And then potassium nitrate aqueous. So this substance has a yellow color. That is the yellow PPT. So having that we use potassium iodide aqueous, we produce lead iodide and then 2KNO3. So lead 2 iodide is also yellow PPT. So we can now go over to question number 2CV. Add to the solution that we boiled. We should add 5 sec of dilute HCl to it and heat it and allow to cool. So this is our solution from 2CI, the one that contains residue and HNO3, which contain lead nitrate for analysis. We now add small amount into the boiling tube. But I told you when you want to heat, use the boiling tube. Don't use the test tube. Then we're going to add hair seal into it. Add hair seal. Are you seeing what happened? What is formed inside of it? A white what? Precipitate formed inside the complete of it. You can see the thing moving down in large amount. Okay? So let's report our work. Here we write white precipitate formed on addition of the HCl. So let's draw a line here. We are now going to heat and allow the mixture to cool. So we are heating it. We are going to heat it to boiling point. And as you heat, you try to rotate the tube. Don't keep it at one point. And don't place it on your fellow student's face. Don't position the boiling tube to somebody's face. As you heat, you try to boil up, you bring it out and come back. See what is happening? That's why I say keep it away from somebody's face. And not keep it away from your own face. Are you following? But before the hot solution, we're going to do what? Pour on your face or somebody's face, and then that gets serious accident or injury. So what do you think happened on heating? Come again. The PPT did what? Dissolved. It's no longer there. And we stop here like this. We stop here like this. Lead what? Lead what? Chloride. Lead have two valencies. Lead 2 chloride. So the PPT are dissolved. So if you heat more, it's still remaining electron anyway. If you heat more, it's going to dissolve. So on cooling the solution, the mixture, the white soda is coming back again, reappearing on cooling. So the salt here is lead 2 chloride. So lead 2 ion is confirmed from lead 2 chloride. So on heating, we say white PPT dissolved on boiling and reappeared on cooling. So this place we have lead 2 ion from lead 2 chloride confirmed. So coming to your analysis, the mixture that was boiled from 2CI contains lead nitrate, and we added HCl to it. We're going to form lead chloride, which is an insoluble salt. And lead chloride gives us a white PPT, insoluble salt. So on the behavior of this salt, when heated, it's going to boil. When you heat this mixture, it's going to dissolve on boiling point. And when you cool it, it's going to reappear as a white PPT. So that's why we have this kind of a result. So thank you guys for staying tuned to this YouTube channel, Best Science Brain YouTube channel. If you're not subscribed to the channel, you move down to the button as the video is playing. Don't enlarge the video as it's playing. Just go down under the video. You have the Best Science Brain, and they have the subscription bell. Tap on it only once and get subscribed to the channel. Then we're running up the May June 2024 A practical chemistry. And there are other questions I've been getting from the YouTube channel with respect to the endpoint titration. The endpoint we got from our video is 3.53 cm cube. That's the endpoint. We are not here to start debating or saying things that are not real or that are not factual. Some people do a lot of gimmicks, a lot of, how would I say, a lot of fabulous mistakes. I don't know what I would call it. Or would I call it, they're trying to impress others by creating some YouTube video of showing endpoint of 18.10, 18.20. That is calculated value. So that is very funny. So if you don't know what you're doing in this chemistry field, please keep off. Keep off. Don't go and start creating endpoints that are not real, that are not authentic. Endpoint of 18.10 is very far. 18.10 is a endpoint obtained from calculation and not from the actual experiment. This is not acid-based titration, for goodness sake. This is redox reaction. So endpoints at most will range from 3.5 to around 12 cm, not 18.10 centimeter or 1800 cm. I was on YouTube, I was laughing over it. Somebody was just fast-forwarding his video, at the end of it, or he just managed to manufacture 18.10 from nowhere. But if you look at our video, you see that we took our time, we showed the initial reading, we showed the final reading until we reach the endpoint. So endpoint, why I say it's going to range from 3.53 to around 12.00 is because the acid concentration may differ. Some teachers are using very dilute acid to acidify the potassium to acidify the iron 2 sulfate. Some teachers are using very dilute acid. No. The acid we should use should be at least 1 molar H2SO for that the ideal concentration for this titration. But whereby you are using 0.1, 0.05, a very dilute acid, you won't get the endpoint be dragged to around 10 or 12 cm cube. You not get a quick endpoint as we got in our experiment. So whatever endpoint you're giving to students, make sure you're giving the students a consistent endpoint. Don't mislead your students. That's what I would have to say here. So because the endpoint you report, your students will be marked or judged based on your endpoint. Our dear students, what I will have to say that you have to use the endpoint that your teacher reported in your school. If the endpoint your teacher reports in your school agrees with that endpoint, that is good. If the endpoint your teacher reports in your own school is different from our own endpoint, then use your teacher's endpoint. Because you're going to be judged based on your teacher's endpoint. If the teacher lies, let him report 70.00. It doesn't one concerns him. Report 100.00, that one concerns him. Use his endpoint. But what I'm trying to say, or what we're trying to say here is this. We are a team of experts. So when you see my face on the YouTube channel, it doesn't mean that I'm doing the work alone. We are experts and in this field and we have years of experience. Most people that are teachers, is unfortunate, are from different fields. People that not read chemistry. You see somebody that read agri-technology teaching chemistry. Somebody that read microbiology teaching chemistry. You see somebody, even if you read chemistry or read chemical engineering or read anything related to chemistry, biochemistry, you must be seasoned. You must have years of experience in practical field. Because some people misplace practical with theory. Practical with theory. That is wrong. Let me go to the board and illustrate something on the board. Look at the equation for the reaction. The ionic equation for the reaction. You have MnO4 plus 8 hydrogen ion plus 5 ion 2, giving us Mn2 plus 5 ion 3 plus what again do we have? Manganese, what again? Plus water. Okay, that's the equation, the ionic equation for the reaction. Look at this, see that the acid has a greater number of moles, 8, compared to ion 2 or manganese ion. That means the acid should be added at high concentration. So if you're using a low acid of very dilute, there's no problem. because maybe for the sake of the students, so they don't harm themselves. Within an acid of low concentration, the endpoint will drag to around 10 or to around 12, which is still good or manageable for this reaction. But don't go and manipulate endpoint of 18.1 and you come to the YouTube and be running around and be telling people that the endpoint is 18.10 or 18.00. Calculated endpoint. That is not good. You don't know what you're doing. We better learn from experts. So having done this, please, there are some questions that can come out in this iteration. I want to talk about those questions before we finally wind up. Some may ask you, explain reason why no indicator was added before the reaction. Why we have no indicator added to iron 2 sulfate is because the potassium manganese 7 solution is a self-indicator. Its color is a self-indicator. You ask, explain why H2SO4 were used to acidify the iron 2 sulfate. Why did we acidify the iron 2 sulfate with H2SO4? It's because it's to prevent precipitation of iron 3 hydroxide, to prevent the precipitation of insoluble iron 3 hydroxide, which will interfere with the accuracy of the experiment. So, some can ask different questions. Some may ask you, explain why the iron 2 sulfate is prepared prior to titration. When you watch the titration, you're going to see that my hands were stained with purple color. My pants were stained with purple. That means I prepared the chemicals immediately and then titrated at once. So it's because the iron 2 sulfate is prepared freshly when it's going to be used, because iron 2 is easily oxidized by atmospheric oxygen to iron 3. So had been I prepared the iron 2 and kept it for a while, for days, it will affect my endpoint. Kept for days or for, I don't know, or hours. The iron 2 content will be oxidized to iron 3. And I'll be titrating permanganate against iron 3, not against what? Iron 2. And then what makes you to know that you know what you're doing as a teacher is this. When you add the H2SO4 to the iron 2 in conical flask before titration, the color of the iron 2 will turn colorless. If it did not turn colorless, that means you're using a very dilute acid. It turn colorless because what the iron 2, because when you prepare the iron 2 solution, there is going to be instant oxidation. Iron 2 and hydros is green in color. Is green in color, and hydro iron 2 is green in color. So when you put it inside water, you don't expect to have a green solution. I got a kind of a fabulous comment from somebody that calls himself a teacher. It's very funny. I don't want to belittle teachers anyway. We are partners. So somebody was telling me that iron 2 is green in color. And when I prepared the iron 2 solution, it was yellow. How come? I told him to go to the lab and do it. When I prepare iron 2 is green in color. When I prepare it, it turns light yellow due to slight what? Oxidation. Now when you add the acid, what is that acid? You add the acid, dissolve the what? Dissolve the iron 3 hydroxide that were about what? Forming, that dissipant. Because you're putting iron 3 hydroxide. So when you add the H2SO4 into it, the iron 3 vanishes, turns to colorless before you titrate. So we are experts on this field. We know what we are doing. We're not here for fun. We're not here for joke. The reason why we open this YouTube channel is for people to know. Like people in Africa don't value online teaching. You see people, you see them wasting their data on frivolities, watching Rio, watching a TikTok, watching comedy, with students wasting their energy. You see them failing examination. That's why we are introducing online teaching. That is the aim of this Best Science. Look at how the name sounds. Best Science Brand YouTube channel. That will introduce it so that people will come to love online teaching. If you look at our channel, we have about over 90 videos in our channel. The videos, we are not only on examination. We're not only on WAEC or NECO or whatever. We teach almost weekly and upload videos on chemistry and physics lectures weekly. We have A-level, we have O-level, we have university work in our channel. Even this reaction between the sodium carbonate and the lead nitrate that we discussed, which is called what? Precipitation reaction. We have done a video on that. Search our channel, you're going to see precipitation reaction where we taught that topic. That was about 6 months ago. So all these things are documented for you to help yourself. Online is valued abroad. It's valued abroad, that is in Western countries, in US than in Africa. So we have to remove the mentality and help ourselves and start manipulating of falsifying figures. If you as a teacher falsify a figure to your student, then at the end of the day, it's a vicious circle. The student will come out and become what? Falsify, become a fraudster. That is it. You have to do the right thing and let them know the right thing. Theory is different from practical. Don't expect WAEC to use the same concentration that they gave in the specimen to ask you the same value in your question paper. They will change it because WAEC cannot ask questions or set examination questions without trying the practical first. So always stay connected. We appreciate people that follow us from our Facebook page. We have a Facebook tutorial page, Best Science Brand Facebook page for those in high institutions. Best Science Brand Facebook group for those in O level. Best Science Brand Instagram. So those of you that are in this particular social media that follow us in this, that followed us in this YouTube, we appreciate you all. We welcome new subscribers. Join us as we move the world. As they say, chemistry recreates nature. Thank you very much.